This is the Microsoft Cloud Show, episode 116, Making the Case, Docker for Developers, recorded live February 24th, 2016. Welcome to the Microsoft Cloud Show, the only place to stay up to date on everything going on in the Microsoft Cloud world, including Windows Azure, Office 365, SharePoint, Exchange, Lync, and related technologies. Just the information, no marketing, no BS. I'm Andrew Connell.
And I'm Chris Johnson.
And we're just two dudes telling you how we see it. Good morning, CJ. How are you?
Very well. How are you?
Doing pretty good. Hey, man, we published our episode 115, I guess, today. It's Wednesday the 24th. So we actually published it yesterday, Wednesday the 23rd, our previous episode, 115 with Ross Gardler and the Azure Container Service. And, man, we've gotten a lot of really good feedback just in the 24 hours we published that.
Yeah, I know. It's been going great. It was awesome to have him on the show. And I love talking to him. It was great.
It really was. I got a lot out of that discussion, even though I was silent for the majority of it with a bunch of kids being loud in the background. So thank you for doing the majority of it and me just submitting questions into the chat. So
yeah, no, it was good times, and it was funny watching you lurk at the other end of the Skype call and laughing in some parts and tapping away in others. So it worked all right.
Exactly. Yeah. So hey, we got a good follow up to that conversation. I think coming up in a future episode with an interview that we'll do so with someone else, but we'll hold off on that for another week or so. In this episode, we're going to talk more about making the case Docker for developers, so why developers should care about this. But before we do that, I guess let me ask you what you've been up to in the last week.
Oh, I've been, Docker Cloud GA'd. I think we mentioned it in the last show. So I've been moving our environment from being managed by Tutum, which was their preview version, with our Docker nodes and things in Azure to Docker Cloud and moving our app over. And it's going pretty well. We're real close. It makes it super simple to stand up multiple different environments and things. And so, yeah, that's what I've been up to, just moving things across.
Yeah, very cool. Yeah, I have been, as far as like the container stuff goes, the Docker stuff goes, I've got a friend of mine locally who is looking at it for his company. He's an architect and he's been looking at it for his company. We've been chatting about it, just the concepts and stuff recently. And so it's been fun to have someone at least local that I can go to lunch with and chat it up with instead of just like you and I going through this stuff virtually and some other people. So it's nice to just shoot the breeze that way. But the big thing I've been working on, I guess, worth note of in the last week has been automate all the things. So the NG Office UI Fabric project that I'm, I guess, being a project manager for, we did another drop today, version 0.5, which is 2 more directives. We're now at 70% of our full coverage for the Office UI Fabric directives, or Office UI Fabric components, having 70% coverage of them with Angular 1.x directives. And what I've been doing is to try and simplify that. The job of managing the project is automate everything. So now I have a script that once the repo is the way we want it for a new release, including the package file that has the new version, the changelog is updated, I run a single script, and that single script will rebuild the library, make sure it runs all of our tests, all of our vetting and everything. If everything's green, it builds the library, it tags the version and pushes it up. But then it also does a clone of a separate repo that we have in GitHub that's called, it's our package repository. It's where we use our packaging for the actual distributions.
Yeah, gotcha.
It pulls that down. It updates the version number, the changelog, and the built binary, tags it, pushes it back up to GitHub. That push notifies a CDN that we have a new version. So they pull in a new version for us. It also it does a build with Travis, but all that build really does is publish the update over to NPM so that we get an automatic update of NPM when we do a release. We now have an automated update with CDN, and Bower always pulls from the Git repo. So Bower's now updated. So now with just one script running, we can do an update of the repos. We can do a complete publish everywhere. The only one that's still a little manual is NuGet, but I've got a script that's almost working to also do an update of that one as well. So it's really slick because now like the manual process of doing all these little updates, it's just one push. And as long as everything is good, all these things just get automated and makes releases go from probably a 20 to 30 minute update that's manual, a lot of manual steps, to really just run a script, sit back and within about 20 or 30 seconds, everything's done.
It's awesome. I love it when a plan comes together.
Yeah. I just don't like it when it says it fails. When it fails, it's a little scary to run it because, so much stuff is you have this like waterfall of automation. So if one thing breaks, you're like, oh, wait, stop. Don't do anymore.
Yeah, that's it.
I've got checks and stuff. But hey, before we dive into the meat and potatoes of this episode, you got a couple links you want to share with our listeners?
Yeah, sure. The first one is an announcement from the Office blogs from the 365 team. It was on February 23rd, which was yesterday for us as we record this, called Auditing, Reporting and Storage Improvements for SharePoint Online and OneDrive for Business. I'm going to be a bit cheeky. If you're still beating your head against a wall with OneDrive for Business, you've got more storage now. I can't. That was cruel.
No, that was honest.
Yeah, that was a bit cruel. Anyway, so they're increasing the storage limits both for SharePoint. So you used to get a certain amount of storage across your tenant. I think it was like 10 gig plus half a gig or something per user or whatever it was. Now you get 1 terabyte plus half a gig per user across SharePoint Online. Plus you get your OneDrive for Business storage on top of that. So enterprise, government, and education plans will receive OneDrive for Business unlimited storage, and everybody's got up to 5 terabytes now. So they've rolled out that first phase. Pretty good. The other thing, which kind of a silent but nice update, was in the sites, behind the sites tile in Office 365. So there's a new sites sort of portal where they've scrubbed up how you can find your sites, recommended sites, recent sites, and followed sites in Office 365. So it used to be a bit of an old experience and it was a bit nasty. And so the Office 365 sites tile now shows much nicer information when you go to it, which I thought was pretty cool actually, because that's been real painful keeping track of all your SharePoint sites and things that you want to go to. So yeah, that's it. Well, we've got a link off obviously from Flipboard, and you can go into all the auditing and reporting stuff. But that wasn't as exciting as storage and the site stuff for me.
Yeah, it's funny you mentioned the OneDrive for Business one. Just this week I finally decided that I had it, and after giving it a shot for 2 or 3 months, since I got the next gen sync client running on my MacBook Pro, I've got OneDrive for Business on my Surface and on my Windows 10 machine. I've just been having minor sync issues, sync sluggishness and stuff. And I finally was just like, I gave up. I switched back. I moved everything back over to Dropbox except for my OneNote notebooks. A little disappointing, but I guess, I don't know. With the ability to have to do like live web-based authoring from Word or Excel docs straight from files that are in Dropbox, I'm not really seeing what I'm getting out of OneDrive for Business now, but whatever.
Yeah, gotcha.
So I have a few bits of news here. I'm gonna go on a tear here and do these guys pretty quick here. First, on the AWS side, and again, all these links I'm going to share with you are going to be available are available today in our Flipboard. One thing is that AWS shipped a new thing called
wait, stop the press.
Shipped a new thing called Lumberyard, and there's another product that goes along with it. Basically, it's helping you build 3D games on the Windows platform and on Xbox and a couple other things in mobile, but it's all hosted and makes it a heck of a lot easier to build, I guess, present day modern games.
Nice.
AWS is a pretty cool product on that. On the Azure side, there's some cool stuff. So first of all, there's something called Log Analytics. It's for Azure virtual machines, and it allows you to bring all of your logs together from all your virtual machines in one spot. It's called Log Analytics, but it's referred to as OMS because it's from the Operations Management Suite. But it's a log analytics resource, and what it allows you to do, like I said, is pull all your logs together from all your Azure VMs. So that's kind of cool. Another piece that we had here is from Azure is that with Application Insights, you now get a annotations detail blade with Application Insights in the Azure portal, so that now when you do a release, you can actually see in the little graphs, you can see a little indicator that shows when you made a release. So you can see the trend of, if you see the trend of traffic coming across.
Ooh, that's kind of nice.
Yeah, you get a nice little call out there. I thought that was pretty cool. And then another Azure thing was I saw a really cool article on the Azure blog on Elasticsearch and Azure file storage. And so what Elasticsearch is an open source product it combines with a couple other products as well to form this thing called the Elk Stack, but it allows you to take data from tons of different sources, put it inside of Elasticsearch, and have a really fast and robust search engine. There's a bunch of different search options that are out there, but this is just yet another one. It's an open source piece. There's a log piece called Logstash that you can pump logs into, and it knows how to feed it to Elasticsearch. And there's another product called Kibana that sits on top of it that gives you a web interface for seeing this stuff.
Yeah.
What's cool about this article is it shows how you can take VMs that you've done in Azure that have Elasticsearch on them, and you can attach Azure file storage to it. They have ARM templates set up for this now so that you can have all of the storage does not live in the VMs for your Elasticsearch cluster. You can actually have them live in your Azure blobs and have them nice and backed up and replicated that way, so you don't have to worry about backing up your VMs, so to say.
Yeah, no, that's cool. It's any way to make that stuff run easier is I'm all for. It's quite hard to set up otherwise.
Totally agree. The last thing I'll go through then is just throw out a few cool Google links that they had. So one is Google had announced, or I guess Spotify announced, is that they've moved their entire infrastructure over to the Google Cloud.
Yeah.
Interesting information about that. There's a cool link on the Spotify blog, and then there's also some stuff on the engineering blog for Spotify on how they move their entire infrastructure over onto the Google Cloud.
Yeah. This is really curious. Like, services this size very rarely move. And it's a huge win for Google. I think it's incredible. They must have dropped their pants on the deal or something, because it's a big win. Like, everybody knows the brand. I'm really surprised Microsoft didn't win it just by giving Azure away. Yeah. For a brand like that, it's totally worth it for the fight they're fighting. At least, who am I to say, right? It might have just been too big a pill to swallow. But it's because services that size don't move very often. There's not very many opportunities to win over big brands like that. And I'm kind of surprised Microsoft either didn't go for it, which I doubt, or didn't win it.
It's an interesting big move. I guess the more I've looked at the Google Cloud, the more it looks like they're almost in a different place than what Azure and AWS are doing. Azure and AWS have this huge feature suite that they're offering, and Azure kind of favors more on the PaaS side, has an infrastructure offering, and now we're getting kind of blurring the lines with more containers, and then AWS doing the same is more on the IaaS side and with a PaaS offering. Google seems to not have that massive feature offering, but instead they have a very narrow, but they're going incredibly deep, and they're really excelling in the area of performance. Like, disk speed is incredibly fast, and like throughput on their network is incredibly fast. So
yeah,
this is going to be fun to watch how this one shakes out.
Yeah, I agree. It's a big win for them.
Yep. The two or three things I want to just throw out with Google as well before we dive into the content. Google and Red Hat announced a cloud-based deal on scalable file servers. So good durable storage in the cloud if you want to have your own like file servers. Google Cloud Vision API entered a beta, so that's where you can upload a picture and you can get keywords back and give you the probability of what things it finds. Like there was one of the demos that uploaded a picture of a bunch of runners, and the phrase marathon was a high hit.
That's cool.
And then the last one, I thought this was really freaking cool. I'd love to see something like this in Azure. There's a thing called the Google Cloud Debugger. And if you have an app that's written in, I think it's Go, Python, Java, or Node, and it's running on the Google infrastructure, the Google stack, you can go to the Google Cloud Debugger, which is it's just a web-based tool. Kind of looks like the Chrome Dev Tools on steroids. But you can get not only some analytics on what's going on live with your app, but you can do live debugging, memory snapshots and stuff. And it looks kind of like if Azure, like I tweeted about this, and Scott Hanselman chimed in, and some other people from Microsoft chimed in, but Microsoft's response is, hey, we kind of do something like this if you look at application insights and some of the tools that we have inside Visual Studio to do the exact same thing.
Yeah.
What is different is that Google's there's no install required, and it's all 100% running through the browser. So I found it to be really interesting. I'd love to have a play with it, but you have to deploy an app to the Google Cloud. So I haven't played at all with Google Cloud deploying an app there. So it'd be something to take a look at. But
yeah, something to play around with. That sounds like a nice tool. Hey, I've got one before we move on.
Sure.
Not technically cloudy, but the Department of Defense are upgrading 4 million seats to Windows 10.
That's a pretty big win.
That's a huge win. I vividly remember when I joined Microsoft, I think it was my first Microsoft conference as an employee back in 2002. Maybe it was early 2003. They did a big Bill Gates gave out, they used to do basically the top salesperson of the year type thing. And there was, I can't remember her name, but there was this woman that won it who had signed the Department of Defense deal. And it was absolutely gigantic. Like, it was an EA, enterprise agreement for 3 years or whatever. And it was like $500 million or something. I mean, it was huge. It was a lot of moolah. And I was thinking at the time, like, how do they roll it? They were talking about 1 million seats back then, right? So obviously the military's 4 times as large or something, or they've got 4 times as many computers at least. But I was like, how do you go about rolling out 4 million seats of Windows? Like, that's a big project.
You say that. I actually was on that. I was on a project like that back in the day. So I worked for a group inside of the Department of Defense called DISA, which was effectively the IT company for the Department of Defense, but it's part of the Department of Defense.
Oh, yeah.
And we were in the middle of this is when Donald Rumsfeld was running it, the DoD, and one of his big programs was, I think it was called the NMCI, but it was effectively like a massive update and unification of all these different systems. And one of them was that we had to go do a complete lockdown, a new lockdown of NSA level security for tons and tons of different machines. I was responsible for 2 different military base installations for IIS and SQL of locking them down to NSA level security, which the funny part of that job was that I did it for locking them down. Took about 20% of the time. 80% of the time was fixing the applications that all broke once you locked them down. But I mean, that was part of it. We had to roll out, I think our group was responsible for about 230,000 seats of updating their desktops.
Yeah.
There's 10 of us.
I just know very little about that stuff. It just boggles my mind.
It's big numbers. It's hard to play with big numbers. Billion here, billion there. It all adds up one day.
Exactly. Nice.
Hey, so in this episode, we want to keep our theme of focusing on Docker and from some of the feedback we've had from some people. So we have a few more episodes of this that we want to get through. We won't do all the episodes like in a string of Docker. If you're enjoying this, let us know. If you want to hear more, if you want to hear something specific, please let us know. And we're also always looking for sponsors. I'll throw that out as well. But in this episode, what we want to talk about is making the case Docker for developers. So we don't want to go like reinvent the wheel here. We've already had an episode where we've talked a little bit about Docker, but I know I've had some questions about some of this stuff, and I just wanted to share one little bit with it to kind of help people that may have this hard thing to kind of gel in their head. People get confused about the difference between Docker and containers. What are the 2 different things? Think about it like this. A container, that is a virtual machine. So think about that's just a generic technology that we just kind of refer to. We have different kinds of virtual machines. We have different kinds of containers. Microsoft's research has built out one. Linux has one. I think it's called LXE. There's Docker, and then there's a couple other ones that are out there. What Docker is an implementation of a container, and it's built on one that came out of Linux or Ubuntu called LXE. So you can think of Docker kind of like a Hyper-V, VMware, VirtualBox Parallels. It's an implementation of a container technology where Hyper-V, VMware, VirtualBox Parallels, those are implementations of virtual machines. And if you're having a really hard time understanding what this whole containerized thing is, just think it's a virtual machine, but then just lop off the operating system part of it.
Yeah, gotcha.
So lop off a huge, massive piece of that.
Yeah, it's instead of everything being in the virtual machine, you're sharing a ton with the underlying host.
Right.
Like the kernel, the memory, the CPU, network cards, all that sort of stuff, in a much less sort of virtualized manner as well. So you're running a container, it's the same OS as the underlying host. You can't be running Ubuntu on a Windows box in a container. You could do that in a VM, but you couldn't do that with Docker, for example. And likewise, I'm guessing you won't be able to run a Windows Server container as that technology emerges out of preview on like an OS 10 box running Docker. Agreed.
So if you want to learn more about about Docker, CJ and I did an introduction episode explaining some stuff that was in episode 106. So if you want to go back, listen to that. And this episode, though, CJ and I want to focus on something about, why developers, why should you even give a damn about this whole thing called Docker containers? And we're focusing on Docker because that really is kind of the industry leader it's seen as like the standard, the most popular one that everyone is kind of gravitating to. There are other technologies that are out there, but we're going to focus on Docker specifically here. So I guess, CJ, one of the things that we need to be careful of with this is that when we talk about Docker and containers, today everything is running on top of Linux. And so this really, if you want to be pure about it, and you want to be like an RTM, general availability supported state, if you're going to do any development with containers today, then you're really working on top of Linux, which means you're doing things with not .NET. You're doing things with Node or with Go or with Python or Java, with applications like that. But I know that a lot of our listeners are coming from the Office 365 world, or they're developers have the same kind of background that we have as Microsoft developers. So let's just say hypothetically, I'm an ASP.NET developer. Why should I even care? Why should I even pay attention to this stuff? Why is this something that, maybe I'm not using it today, but why should I at least just kind of, have it off to the side and pay attention to what's going on?
Yeah, I think that's a really, really good question, because you could, on the one hand, you could say, hey, none of this is applicable to me, and move on and just stick with what you're doing now, or knowing what you know now. Or on the flip side, you could see what's coming, right? And what's coming is, Microsoft's opening up a whole lot more to the open source world. You're seeing the open sourcing of .NET. And one of the key pieces of that is being able to run .NET on different platforms. And you've been able to do this sometime with Mono and the likes, but Microsoft are taking a stance that .NET should run everywhere. And so you're seeing that with the new .NET Core, I think they call it .NET Core 1.0. They've reset the versioning and things. And so eventually you'll be able to run ASP.NET apps on Linux boxes or on Windows boxes or wherever you like. And that means that your world of opportunities and or options, I should say, not opportunities, is going to open up in the next 12 to 18 months. And so you're very, very likely to see SharePoint developers and Office developers being able to build solutions like they do today, but on whatever sort of technology they want. And it doesn't really matter where you deploy it. So you write an app, run it on Ubuntu or on Windows, doesn't really matter. Like the running of it, fades away into the background. The other key piece there is that Windows containers are coming. So even if you don't want to go build your ASP.NET stuff and run it on a Linux container, you're going to be able to do it on a Windows container very, very shortly. And in fact, Windows containers are already out in technical preview in Windows Server 2016, I believe it's called, right?
Yep.
I haven't been keeping tabs on exactly what technical preview they're at right now. Technical preview 4, maybe?
I think
something
so.
like that.
Yep.
But you can go play with this today. You can go download Windows Server Technical Preview 4 and play around with Windows containers. And that's very exciting, because that means regardless of what your company is cool using, or regardless of whether they're cool using, Linux in their environments and things, if they're a Windows shop, then that's going to open the whole world of containers up to you, to Windows developers, which to me is extremely exciting, because that means everybody's able to participate and it's not quite as closed off to the Linux guys right now as it is right now.
Yeah, I completely agree with all that stuff. I think that, the key thing here is that, today, if you're focused just on the GA world, then yes, it is Linux only. But for you .NET guys that are out there, you've got two different sides where, one, you could do this stuff cross-platform to where you build a website or you build an application and you don't have to worry about, oh, no, it only is going to run on Windows, right? You can say it's going to run everywhere. Kind of like the same way we do websites today, right? We build a website and we don't say it's only available to people who are on a Windows machine. You could say, no, you're on an iPad or OS X. It doesn't matter. It's a website. So you have that opportunity. And the other side is that, if I am going to be just sticking just with Windows, I'm building stuff just on Windows, which is perfectly fine. And I would expect the majority of .NET developers are probably going to stay in that camp. They're not going to all of a sudden rush over to say, now I can build stuff over on Linux using .NET. The fact is you can still keep using your ASP.NET version 4 stuff, or you can build your, .NET FX4 applications, and they will still run in this container space because Windows Server 2016 is bringing containers to the Windows platform. So all that stuff is happening. It's happening right now. Microsoft is well on the way, and we very well, I wouldn't be surprised if we see, one of these products release, as in the .NET Core, maybe going RTM or GA at the Build conference in a few months. I have no insight into that stuff, so it's just that's typically where, big dev stuff like that happens. So
yeah,
curious kind of news there. So everything that CJ are going to talk about in this episode, it does apply not just to people who are focusing a lot on open source based stuff or Node or Go or any of those kind of languages, but it does also address, and it does impact everybody that's over on that's a traditional ASP.NET or .NET developer. It doesn't force you, but it gives you an option. So you're not kind of like, I can't play with that stuff. I got to learn all this new stuff to do it.
Yeah, exactly. It's going to be good. So for me, it's pretty cool because if you're a Node developer, you can run on Linux containers today, or you could run on Windows containers tomorrow. Mm-hmm. If you're an ASP.NET developer, you're going to be able to do the exact same thing. To illustrate the point, when our website is written in, it's very, very basic, right? But it's a Node application, and we develop it on an OS 10 machine in the office and deploy it in Azure, and assuming it's running on Windows and Azure. Mm. It's not in a VM, it's in an Azure website, and it's a Node app that runs up there. So it's sort of platform agnostic, and being able to do that with ASP.NET is pretty cool. And it just means that your hosting kind of fades off into the background. Like what it runs on shouldn't really matter.
Yeah, I mean, if all of a sudden Google has a great offering for Node.js websites that'll run for free in a very robust and fault tolerant and scalable way, you may decide, hey, I want to switch and move it over to Google because it's a much cheaper option than what I'm getting with Azure. Or, Azure comes back and you could move things around and you're like, I don't really care. It's that this stuff runs anywhere it's going to run.
Exactly. Yeah.
You touched on something just a second ago too, about you built your website on OS X and it runs in different places. Let's talk about this as the container space. And you spent a little bit more time with this because, cards on the table for our listeners. You're working at an incubator startup. You're building an application, and the app that you're building, you're using containers for your hosting model, for your deployment model.
Yeah, that's right.
Okay, so you've got some real world experience here with this, on using this and how some of the advantages to this. So this is firsthand. This is all mostly, I do it myself, but I don't have a team that I'm working with or really pushing stuff into production yet. So let's talk about like the development environment. So one of the big things that people tout around containers is that the development environment is exactly identical to all of your different deployments. So why don't you take us through a little bit of, this experience that you guys have and why this is an appealing option for you, and compare it to, like, say, what you might be traditionally used to doing if you weren't using something like containers. What would your story look like?
Yeah, I think probably the best place to start with that is the famous quote of "it works on my machine," mm-hmm. right? And we've all heard it, right? A developer will write some code and it'll work flawlessly, and then they hand it over and into whoever's sticking it into production or whatever, and it all breaks for whatever reason. And it all boils back to it's very hard to make things equal between different environments, whether that be the OS that runs it, or the types of CPUs, or the number of machines that are running it, and the setup and everything. It makes it really hard to know when you write a piece of code on your dev box that it's going to run the exact same way in production. And this is kind of a thing that developers and IT have been struggling with for a long time. But one of the things that Docker does is it sort of takes a lot of that out of the equation. It doesn't take all of it out of the equation, but it takes a few more bites of the apple, so to speak, towards that nirvana of same on my machine, same in production. And it gets pretty close. So, for example, when we're developing our app, a developer will run the entire environment on their laptop in Docker, right? So it might be, 10 or 12 different containers currently, which range everything from a database to the front-end web application. And they can do that very straightforwardly and easily. All they have to do is install Docker and pull a few source files and hit go using Docker Compose, and it spins up the whole environment. And there's some other tools that do similar things, like Vagrant is another one that people may be familiar with. But the idea is that developer can get up and running super quick with an environment that very, very closely mirrors what it will be running in production. And by that I mean, so when you spin up a container on our dev boxes, it's running the same underlying OS and environment that it does when we deploy it to our Docker nodes up in Azure. And therefore, the sort of the differences are minimized as much as we can. Now, that said, there are some things that leak through. Like one that I've noticed, if you're developing on OS 10, I think I brought it up in the last episode, was file name case sensitivity. And OS 10 does some weird things with file name case sensitivity that pure Linux doesn't. And so you can strike some differences. So it's not completely perfect is what I'm getting at there. But yeah, the idea is that you're getting as close to how it is in production as possible in a real simple way.
Yeah, if you think about, like, I guess one thing for listeners to kind of to think about here is that when you, like, let's say for example you're going to build a website and you want that website to run up in an Azure website. If you're going to do it with .NET, if you're going to do it with Node, it doesn't matter what the language is or the platform is that you're using. They're all hosted up in Azure websites. But when you build this and you test it and you're running it locally on your machine and it's running it inside of a little web server, when you deploy that up to Azure websites, for the most part, it's going to run, it's going to work just fine because they've made it to where the developer story for this is so much cleaner and so much easier, where it really does mirror what the environment's going to be like. But it's not exact. No. And I would normally use the word container, but I'm going to use the word box instead. The box that you're putting your application on where it's supposed to run, you can't mirror an Azure website on your local machine the same way that it runs up in Azure. You can't mirror the way that, configuration variables or the app settings where you can modify them in the dashboard and have them trickle down and be passed in as overriding values inside of a web config. You can't do that locally. That's just one of those things you just have to push it up and see it run up inside of Azure. And that's one of the things that's a bit of an advantage that we have with something like a container, is that I know that the box that I'm running in, the container on my local machine, that box that runs up inside of whatever hosting provider I'm using for my containers is going to be the same thing. I can see what it's going to look like locally, the same way it's going to work up in the cloud and across different providers and different platforms. So I see that as being a really big benefit.
Yeah, one of the examples of these differences I just gave, but another one is when we deployed our Node website to Azure websites, things didn't work. And you'd think it's a Node site and it should just work, but there's a bunch of intricacies about the way Azure websites run Node applications that you have to know about. Azure websites takes away some of those intricacies for you, except when things go wrong, you've got to debug. And so setting debug flags and stuff like that in Azure websites, there's some peculiarities of the way Azure does it that you need to understand. Whereas in a Docker image, there's just a whole lot less differences, and therefore you stumble across less of those problems. Yeah,
and so another thing that you talked about was that, one of your developers, when they want to go build the entire environment, they run the entire environment.
Yeah.
Let's say, for example, you're going to have look at a standard kind of web-based application you're going to build. You're going to have a web front end. You may have an API, a REST API associated with it.
Yep.
You're going to have data that you're storing inside of some, persistent store, some sort of a database. And then you're going to have, say, maybe even a caching layer as well. So if you look at this, there's a couple different ways you could obviously architect your application. But let's say, for instance, that I'm going to host this up inside of Azure. So I've got my website. I build in whatever technology I'm going to build it in. I've got my REST API. Use whatever I'm going to use, be it Node, .NET, Web API. Web API is referred to as .NET, but that technology discussion doesn't really matter. I want to store my data inside of a SQL database, right? In Azure, I have an option for that. My option is to do the SQL. I have two options, actually. I can either have Azure SQL Database as the PaaS offering, so let Microsoft host SQL for me, or I have my own virtual machine where I have SQL installed, and the same thing with the caching, right? So I can use the hosted service that Microsoft Azure provides in the Redis cache offering. So let's say I take that same kind of example there and I want to pull that down into, say, my container infrastructure. And you're like, you look at this and say, well, now hold on a minute. You're not really saying you have the entire environment running locally, because if you're using a hosted service like Redis, or you're using a hosted service like Azure SQL DBs, then you've got some stuff that's running in your containers locally, but they're still making these remote calls. So are you really saying that you're running everything locally, or are you really running on your local machine? Or is there really this hybrid model? Why don't you take us through a little bit of that?
Yeah, we've opted to go for the non-hybrid model. So we do run everything locally. So we take a dependency on Redis and we run a Redis container on each developer's machine. When they spin up the 10 or 12 containers, one of those things is a Redis cache container. And we do that so that it's all isolated to that developer's box, and provisioning it's super simple. We do the same thing with the database. So we use Postgres for this reason. Each developer can, when they hit Docker Compose up, right, it spins up all those containers, and one of them is a Postgres container. So they've got their own isolated database. Now, in in a lot of places or in a lot of environments, typically how people would do this is they'd either have to have SQL. If you were using Microsoft SQL Server, you'd have to run that on your local machine, or you'd have to spin up a virtual machine with that in it, or you'd have to use a shared database somewhere out on the network, or have IT create you a SQL Server instance with a database in it just for you, for each developer, and that's kind of painful. But in comparison, at least I think, versus pulling a Docker image down, spinning it up, and you're up and running in no time at all. Now, there are some differences. You do bring up a good point that in production we don't run that way. So in production we don't run Redis in a container that we run, and we don't run Postgres in a container that we run. We use external dependencies for Redis and Postgres. We use Azure to give us a Redis instance, and we use a hosted Postgres managed service that runs in Azure, but a third party runs it. And we do that because we can't run Redis and Postgres as well as those guys can, and so we choose to offload those out. But I don't know how they're running those. I don't know if they're running them in containers or not, and I don't care.
Yeah.
By and large, we haven't seen any differences between Redis and Postgres running where we have them in production versus in a container. So maybe they are containerized. I don't know.
So just to summarize, then what you've done then is you're in production or in your staging environment as well that you have hosted up in the cloud. You've elected to use a hosted service and combine that with your application you've built in one or multiple containers. And then the applications can actually use this hosted service, and they really only need something like a connection string to connect to the Redis cluster or to your database connection using Postgres.
Yeah, we do that for Redis, Postgres, and RabbitMQ for message queuing. And, you could say I just completely contradicted myself in saying we want dev to be as close to production as possible. And you'd be right? Those three things are different in production. But the point is, we could be running those things ourselves in containers. It's just for those particular pieces of our application, we feel these other guys can run it better than us. And so we're choosing to use them for now. Like if I wanted to run it in production, it'd be a simple config change. We'd spin up a Redis container in our own production environment, and it would be a 10-minute job. But
it's just a connection string. And one of the advantages to using these different, the things you've chosen using Redis, and the reason you chose Postgres was it was more that there was a hosted offering, but then there was also a containerized offering. And the containerized offering, these are containers that are already out there, fully supported by these different vendors. And you just need a little bit of configuration changes, like the name of it, the database connection, the login, the you're going into the schema and stuff. And that's all the same things that you would provide that container that you would provide Azure if they're hosting the Redis for you, or they're hosting these different databases for you. So your dev environment it's still, your application doesn't know the difference of those changes. Those little hotspots that you've identified that are containers in your dev environment, but are hosted services in your production and staging environment, it's really just connection strings to your application. They don't need to know about the other intricacy details for that stuff. Yeah, right. Exactly. So I think about how we do this now versus how I would do this in a .NET world with production ready stuff today. So outside of containers and things like that, right? And it would be quite hard. At least it seems more complex to me. So say I had a typical ASP.NET app, and it had a web front end and an API and a database and maybe a cache, for example, right? I'd have to run Redis locally. I'd have to run SQL Server locally. I'd have to run 2 web projects, one for the web application and one for the API. And I'd need to configure a box to do all of that, right? So I'd have to install IIS, SQL Server, Redis, all those things, or I'd have to have virtual machines with each one of those things configured, or all in one box and spin it all up to get the whole application running. And that's a few different things you've got to do, and either you script the install, or you have some sort of repeatable process, or every developer is doing things differently. And one of the key pieces to developer productivity, as I've done this, is being able to stand up a dev box in like 15 minutes or less. Like if you can't start from a fresh install of whatever operating system you're using and be developing on your application in less than 15 minutes, you're doing it wrong. Gotcha. That's critical, right? Because if you can't do that, it's not a repeatable process, and you start doing weird things. Like say your app starts breaking and you're not sure if it's because you installed like some, toolbar in IE that's added malware to your box, right? If you've got no idea what you've changed in your environment and things start breaking,
if you can't just tear the whole thing down and stand it back up in 15 minutes or less, then you're wasting hours trying to track down random environmental things.
Yeah.
And so it's critical. Like for us, it's super easy. You kill all your Docker containers, you hit Docker Compose up, and you've got a fresh environment starting from complete scratch. New database, new Redis cache, and all of the various containers that compose the application are stood back up, and you're good to go.
So let me be a bit of a devil's advocate here. Let me be a devil's advocate in this case. So someone's listening to this and they're saying, okay, that's all fine and good, but let's say that they say, couldn't I do this exact same thing with virtual machines? I mean, the answer is yes, you definitely could, but there are advantages to going with an option like this with containers instead of working with virtual machines. To me, I'm interested to get your take on this, but to me, I mean, there's a couple advantages you get. First of all, the two biggest downsides to virtual machines are, number one, you're owning the operating system as well. So you've got to be responsible for patching and updating. I've got a friend of mine that, yesterday just said that his entire afternoon, he's got like 10 different VMs that he has to use, but for managing different environments for a desktop application that he runs. And it was update Tuesday. So he was spending about 4 or 5 hours updating all these different virtual machines. So you're still responsible with virtual machines. You're responsible for the feeding, the watering, the patching, and all that stuff. Make sure that they're all still running and everything's good there, and the backups and such. The other thing, though, that's a huge... So if you wanted to use virtual machines to be able to deploy your stuff, sure, you could ship those VMs up to your hosting provider. But the virtual machines have got, they're giant. They're huge, tens and tens, if not 100 gigs of information. So shipping that around is not exactly a trivial task when you want to update your application.
Yeah, there are some tools like, I think Vagrant, I mentioned earlier, is one that runs on Windows and OS 10, uses things like VirtualBox and stuff like that. And I believe that I haven't actually used it in real world. I've only heard about it, so I could be off base here. But this helps you effectively script a whole setup, like, basically templatize a whole setup of pieces of your application, being able to stand it up using virtual machines. So that could be something that could help with, if you are doing this today through the VM route and you're in that world, then, and you've got multiple different pieces of the puzzle, you could use something like that to help with it. Gotcha.
Yeah. So another thing, then, the other big benefit to this too is that virtual machines they can take minutes to spin up, and they take a lot of resources. They can take a lot of time and a lot of resources to spin up and get running. Containers. What's your experience like this with containers?
Well, anybody who's done any SharePoint development knows you want to be doing it in a 8 or 16 gig virtual machine, right? Because of all of the, it's got SQL in there, it's got Windows in there, it's got SharePoint in there, it's got a lot of memory gobbled up by various pieces. Doing this in containers is super quick. Not SharePoint development, obviously, but application development. It's because you're not spinning up a whole virtual machine and booting entire OSs and things like that. It's super, super fast, and it's a matter of milliseconds to get a container up, and then your app boots, and that can take however long your app takes to start. But versus starting a virtual machine, it's kind of like cold booting your desktop PC versus switching your screen on and off on your iPhone.
Yeah, it's pretty eye-opening when you first see a demo of this, when someone wants to go through and create an instance of a new container. And if it doesn't already have the image, it's got to pull the image down, which is we'll touch on that later. But it's just how fast that these different containers spin up, or when you want to spin multiple instances of the same container up, if you're doing like a load-balanced app. It's absolutely fascinating. I saw a guy, spin up, I think, 150 containers in a matter of about maybe like 5 to 10 seconds. And it's just... It's mind-boggling.
Yeah, the interesting thing about that is you're not dedicating resources to a container. So, for example, you can spin up 100 containers on your laptop with 4 gig of RAM. They're not all getting 512 meg of RAM each, right? They're only getting the RAM that they need to run the app that they're running.
Right.
You're not dedicating CPU to it. You're not dedicating RAM to it. That sort of thing. It's all shared with the underlying host. So that's how you're able to do things like that.
Okay. So I have one final question for you, and this tripped me up at first, and I've seen a couple questions of this come up as well. So let's think, implementation-wise. I want to sit down and I want to build an application, and I want to run it inside of a container. when I'm doing this inside of a virtual machine, I know that I'm, RDPing or connecting into the virtual machine and doing the work inside the virtual machine. When I'm doing this inside of a container, or when I'm building an application that's going to run inside of a container, am I doing the same thing? Am I starting a container up and then I'm connecting into it and doing my dev inside of this box?
You can. I mean, there's a couple of different ways to skin this cat. Some people choose to do that. Some people choose to spin up a container and then like SSH or a terminal into it and do their development in there. But what Docker offers as well is mapped volumes. So what happens there is you can continue to work on your code on your local machine. So say it was a Node application, you have a folder with some files in it, right? And you're working on the code in those files as you normally would. And you spin up a container to run the app. You can map a volume between your local box and into the container. So it's kind of like a shared folder between the two. So when you edit files in your local box, it's reflected in your container. And then in a Node world, you run something like nodemon or something like that that's watching those files, and it restarts the Node application when one of those files changes. So you're editing on your local box, you hit save, your app inside the container reboots itself and restarts because it's seen an edit happen. And so you don't really need to you don't really need to get into the container to do that. You can watch its output. So often I'll have a window open which is showing the output of the application, much like the debug log or console out from the application, so you can see what it's doing. But I don't need to terminal. You don't really need to terminal into the machines or into the containers to actually do your development. You could do it all locally. Use mapped volumes into the containers so they can get the files in the container and then run the app runs in there. And
the other option that you can do as well too, if I'm not mistaken, is that if you want to go create your Docker images at the same time as you're doing your builds, part of your build process is to say create a new image. Now, not shipping it anywhere, but just creating it locally. So you create a new image and say now go spin up the container, and the container spins up an instance of the container based on the image you just created, so that if you have, like, if you're building a Node or a NuGet based app, if you're building a Node or a .NET application, you have things you're pulling in with, like, say, NuGet or NPM, or you've done stuff as TypeScript. There's a compilation process so that you can say you create inside that application. You've got a thing called a Docker file, which it literally is just a file named Docker file. And it has a list of, you want to start with this base image, and then here's all the stuff you want to do to that image to create a new image that I'm going to call Andrew's application, which is, compile everything into TypeScript, do an npm install to pull all of the Node packages or the NuGet packages that I need. Basically create the image so that it looks like this picture, so that when you create a new instance, a new container based off of this image, and you start the application, I want it running and I want it to look just like this. So you can have that same experience to where you're not doing live dev inside of a container, but you can say, go spin up the container based on this application I just built. Yeah, you can. We don't do it that way because creating a Docker image every time you want to build can take a little bit of time. And it sort of slows developers down a little bit. So we choose to do in development, we choose to use mapped volumes for source. So it maps your entire app directory, including your Node modules and all of your source files you build the image once, spin it up, it maps the volume, and then all your edits are in real time inside the container. Just because building a Docker image each time can take a little while, depending on how complex your container is. So we choose not to do that. But we do that when somebody commits code. We have a continuous integration server that picks up those changes and builds the Docker image. Gotcha. And so the process you're talking about with like that shared volume, that's very much like if you're doing, you could do that same kind of a concept with, say, a virtual machine where, you spin up a virtual machine, it's got a shared drive. Yeah, shared folder or whatever. Shared folder back to your local machine, and you do all your dev local, but stuff is actually running in a separate environment. Yeah, correct. Gotcha. Yep. Cool. Oh, well, we covered a bunch of stuff here. I know there's a lot more stuff we want to talk about for developers, but I think that we have another episode we want to do about if you want to build, like, quote unquote, you want to build a containerized application, like what's the stuff that you're looking at, like updates and shipping updates and development, continuous integration, some real scenarios. Yeah, how do you move from like a big monolithic app to a more containerized app over time is an interesting topic that
lots of people have questions about, and we should cover off at some point too.
Yeah, that's definitely a different episode, though. We don't want to go. We don't go people too long. They've got hour-long commutes, so we want to make sure we keep the episode right in their commute. So, is there anything else you wanted to throw in here before we sign off?
Yeah, the only thing I'd say is, looping back to what we began with, that this might not be your world today, and it might not be your world for a little while yet. But it's always good to stay on top of what's coming, right? And this is coming to the Windows world very soon with Windows Server 2016 with containers. And so sooner or later, I think it's going to be part of everybody's lives. And it certainly changed. This is going to sound super cliched, but it certainly changed my life, right? In terms of as a developer, the way you build applications and things. It was freaky and scary and kind of weird to begin with, but I just can't see myself doing it any other way at the moment.
I'll echo that. The more that I am reading about this, the more I'm playing around with it, the more I dive into it, the more I'm kind of looking around and just saying, I don't understand why I would build an application the big monolithic way anymore, that this option is just so nimble. I know I'm on a MacBook. I know I do primarily stuff with Node, but I mean, switch me back over to C#, ASP.NET, and Windows, and it wouldn't change my opinion of this in the least bit. In fact, it's even more reinforced by just being able to jump around and use these different capabilities. This different technology is cool. With the way that Docker has been growing, I think just yesterday or today was Docker's 3rd anniversary. So watching this technology really just explode in terms of popularity. It's kind of like, you go back 10 years and when virtual machines were still just kind of coming around, some people said, yeah, I'm just not really interested in it. But I mean, I think it's kind of hard to say that any developer has been able to completely avoid any kind of virtual machines or virtualization technology. I see this as the same, if not even more so, one of those kind of emerging technologies you just can't get away from.
Yep, I agree.
So maybe not this year, maybe not next year, but it definitely will be in somewhere along the line. So
yeah, I agree. It's inevitable.
Awesome. Well, hey, good discussion, man. Thanks for sharing some of your experience and real world experience doing this, and another episode in our Docker series that we're running here.
Yeah, absolutely. We'd love to get feedback on this. So if you have questions, please email us as per usual. The instructions are at the end of the podcast. Or get in touch with us on Twitter. Both AC and I are pretty prolific Twitter users, so we'd love to hear from you.
Yeah. So the podcast is at MS Cloud Show. That's the Twitter handle for that. I am Andrew Connell, 2 N's, 2 L's on Twitter. You are LoungeflyZ on Twitter. So we're easy to get a hold of, easy to find. Please go in. Please, give us some feedback. We'd love to hear about this. Please drop us some reviews and iTunes as well, because those reviews help us reach additional people and get more ideas for additional shows and hear what people are interested in hearing about. So really curious to hear where we go with this.
Awesome.
Thanks a lot, CJ, and I will talk to you again next week.
Rock on.
If you have a question for us, go to microsoftcloudshow.com/questions, where you can submit it as text. We'll record it as a WAV or an MP3 file and provide a link so that we can play your question on the show. Our theme music is an excerpt from Evaporated Eric by Monk Turner, used under Creative Commons. You can subscribe to us in iTunes by searching for the Microsoft Cloud Show or via RSS at microsoftcloudshow.com, where you'll also find a full transcript and show notes of each episode. You can find us on Facebook searching for the Microsoft Cloud Show or on Twitter at MS Cloud Show. Thanks for listening. We'll see you next time.